fellow mathematicians, and welcome back to the Art of Integration. We're going to evaluate a beast of an integral using our peculiar property of definite integrals known as the king rule. This problem is going to be a little bit lengthy, so we're going to split it into a few parts or steps. For our first step, we're going to apply this peculiar property, the king rule, in the version that I like right here. That'll be our first step. All the work after that is pretty much applying a bunch of trig identities. So with that out of the way, let's get to step one, applying the king rule. For our first step, we're going to start by applying the peculiar property of definite integrals in the version that I like. So we're going to rewrite our integral here with a factor of 1/2. Our integral goes from 0 to pi over 2 still. And now we have two terms inside the integral. We have the original function here, natural log of sine of x. And then from our peculiar property, or the king rule, we have another term, the function with a plus b minus x plugged inside. And here, if we go ahead and replace that, a is 0, b is pi over 2, what we get is natural log of sine of pi over 2 minus x. All right, from here, most of the work, again, is going to be applying trig identities. And the first place we can apply one is inside this natural log function. Sine of pi over 2 minus x, that's equal to cosine of x. So we can rewrite our integral here. We have our factor of 1/2 out front. Our integral still goes from 0 to pi over 2. And we have natural log of sine of x, but now plus natural log of cosine of x. All right, from here, use your intuition. We're going to apply properties of logs to combine these together. We can rewrite this inside the integral as natural log of the product sine times cosine. All right, this is looking slowly but surely a little bit better. Again, from here, we're going to apply another trig identity inside the natural log function here. That looks close to the right-hand side of the double angle identity. So we can rewrite this. We're going to have our factor of 1/2 out front. Be careful not to lose that. And if we apply the double angle identity in here, we can rewrite sine of x times cosine of x as 1/2 times sine of 2x. So we get natural log of 1/2 times sine of 2x. All right, we already applied properties of logs already, going from here to there. Well, let's go ahead and apply it again. We have a product here, so let's go ahead and split that single logarithm apart. Just be careful. We have this factor of 1/2 there. Again, don't lose that. That's going to be key to getting the exact value that we're looking for. So let's go ahead and carry the work down here. We have our factor of 1/2. Our integral goes still from 0 to pi over 2. And we're going to split this term apart using properties of logs. So we have natural log of 1/2, and then plus natural log of sine of 2x. All right, from here, we're going to split this single integral into two integrals. And again, just be careful, this factor of 1/2, that's going to be on both integrals. So we get 1/2. The integral from 0 to pi over 2 of natural log of 1/2. And that is a constant, so that's going to be very easy to integrate, which we'll get to in a moment. But don't forget the other integral here with your factor of 1/2. This goes from 0 to pi over 2. And that's now for the function natural log of sine of 2x. All right, now to proceed, we're going to rewrite this a little bit in a nicer form, I'll say. Natural log of a half, you can rewrite 1/2 as 2 to the negative 1. And you can go ahead and apply properties of logs to bring that exponent down. And we can rewrite natural log of a half as negative natural log of 2. Now, if you go ahead and evaluate this integral, because you're integrating a constant, what we basically get here is we have our factor of a half. We have negative natural log of 2. And then if you evaluate that integral, you get basically x as your antiderivative, plug in your limits, and you'll get a factor of pi over 2. All right, the other integral, we're going to leave that alone temporarily. So plus a half times the integral from 0 to pi over 2, natural log of sine of 2x. All right, and if you just go ahead and clean up this constant here, notice we can multiply those factors of 2 in the denominator. So it looks like here we're going to get negative. We have pi over 4, and then times natural log of 2, and our remaining integral here. So plus 1/2 times the integral from 0 to pi over 2 of natural log of sine of 2x. And that's pretty much it for step 1. What we're going to get to next is evaluating this integral here. The integral from 0 to pi over 2 of natural log of sine of 2x. And just be careful, we're going to keep this factor of 1/2 there, and we'll get back to this at the end of the video. Let's go ahead and get to evaluating this integral for step 2. For our second step, we're going to start by applying a simple substitution. If you take a look at the integral that we're trying to evaluate, which involves natural log of sine of 2x, you might be tempted to try a substitution of the form t equals 2x. So let's go ahead and try that. So here, we'll substitute t equals 2x. And we're going to convert this x integral to a new integral in terms of t. We're going to calculate the differential, dt. It just comes out to 2 dx. And from here, we're going to convert everything. First, we're going to convert the differential dx just by dividing 2 to the other side. We'll write this as 1/2 dt equals dx. And one thing I always like to do when doing a substitution with a definite integral is to change or convert the limits. So we're going to start with our original x limits, which go from 0 to pi over 2. And we're going to convert them to new t limits using our substitution. From here, we just plug in. First, plug in x as 0. You'll get t as 0. And when you plug in x as pi over 2, you get t as pi. All right, we have all the pieces to do the conversion, so let's write it out. From our differential, I'm going to pull this factor of 1/2 out in front of the integral in terms of t. So we have 1/2. Our integral in terms of t now goes from 0 to pi. And inside the natural log function, we have now sine of t. So we get natural log of sine of t dt. Now this looks close to our original integral, which involves natural log of sine of x. Don't be concerned that the variable here is now t instead of x. Here we call t or x maybe a dummy variable. But notice our original integral goes from 0 to pi over 2, but now we have this going from 0 to pi. Well, we might be tempted to split this interval from 0 to pi up into 2 smaller intervals, one from 0 to pi over 2, and then another one, pi over 2 to pi. So we'll apply a property of integrals to do that. Just be careful with your factor of 1/2. You don't want to lose that. So we'll have 1/2 times, and we're going to split this integral apart, So we'll get an integral from 0 to pi over 2, natural log of sine of t dt. And then another integral, and be careful, that factor of a half will distribute. So we have a factor of a half times the integral from pi over 2 to pi. Again, keep in mind, we're splitting that interval from 0 to pi up into two smaller intervals, giving us these two separate integrals. So pi over 2 to pi of natural log of sine of t. All right, and that is most of the work for step 2. What I want you to notice is this integral right here. That is exactly our original integral. So buried inside this integral up here, we have our original integral, but we get another integral that looks close but not quite right. Notice the function is the same, natural log of the sine function, but our limits aren't quite right. Well, for our third step, let's go ahead and evaluate this integral with another substitution. For our third step, which is evaluating this integral, we're going to try to use a substitution to change or convert these limits pi over 2 to pi somehow back in terms of the original limits 0 to pi over 2. And if you play around with various substitutions, you might find we can try a substitution of the form t equals pi minus a new variable. Let's call that new variable theta. So we'll try a substitution here of the form t equals pi minus theta, where we're thinking of theta now as our new substitution variable. We're going to calculate our differential still, dt. Thinking of theta as our variable, that's going to differentiate to -1, or just negative d theta. And we're also going to change or convert our limits from t limits to now new theta limits. To make that as easy as possible, let's just go ahead and rearrange our substitution here and solve it for theta. So basically just add theta, subtract t, and what we'll get is theta, our new variable, equals pi minus t. And that's going to make it a little bit easier to change or convert our limits. So let's go ahead and do that. Our t limits go from pi over 2 to pi. And we're converting them now to theta limits. And we're using kind of this rearranged version here, solved for theta, where theta equals pi minus t. All right, and if you go ahead and plug in your values for t here, just be careful, you have pi minus pi over 2. That'll simplify to pi over 2. And notice when you plug in t as pi, you'll get theta as 0. And there are the original limits that we were looking for, but they're kind of flipped, and we'll deal with that in a moment. So let's put all the pieces together. We're going to convert our t integral to now a theta integral. Just be careful, dt, we have a factor of -1 there. I'll pull that out front. Our integral for theta now goes from pi over 2 to 0. And to take care of the limits kind of being flipped there, eventually we'll flip them momentarily. And then our function here, we get natural log of sine, and then we're going to replace t with pi minus theta. So we get natural log of sine of pi minus theta d theta. All right, first thing we're going to do is flip our limits there. And when you flip your limits of integration, you can exchange a negative there. So we'll get an extra negative when we flip this. So flip your limits, we'll get a negative to cancel that out. So our integral now goes from 0 to pi over 2. And this is where we're going to now apply another trig identity. Inside this log function here, we have sine of pi minus theta. And in the beginning of the video, we kind of gave a brief overview of some trig identities that we're going to need. And here, sine of pi minus theta, that equals just sine of theta. And what we get here is our integral from 0 to pi over 2, our original limits, and then now natural log of sine of theta. And that is exactly our original integral. Just here we're writing it with theta as the integration variable, but up here we have it written in terms of x. We can change those. Again, those are referred to as dummy variables, so we'll get to that right after this. Now this is most of the work. We split it into several different steps. Now we're just going to kind of work our way backwards and put it all together. So we're just going to, again, go backwards here. This integral from pi over 2 to pi, which was right here, basically becomes our original integral. And when you go ahead and plug that back in here, we'll get some nice simplifications, allowing us to easily evaluate our original integral up here, really without ever finding any antiderivatives. Let's go ahead and put all these pieces together. At this point, we're ready to put all the pieces together. From where we left off with step 3, we showed that this integral going from pi over 2 to pi for this function, natural log of sine, that equals the integral from 0 to pi over 2 for the same function. Now, the variables here that we're using in these definite integrals are different, but it doesn't matter. The variables here are sometimes referred to as dummy variables for definite integrals, and you can just change them to whatever you want. So here we can replace theta with t, and that's going to allow me to take our integral here from the end of step 2 and replace these limits, pi over 2 to pi, with the limits going from 0 to pi over 2. So let's go ahead and do that. We get now limits going from 0 to pi over 2. And just to be clear, we're going to change the use of the variable here, theta, to a different variable, t. Now what we're going to notice is we get exactly the same integral here as the other part from what we saw in step 2. So we have two of the same integrals. We can go ahead and add them together. And what we get here, 1/2 of something plus 1/2 of something equals a whole. So we get the integral from 0 to pi over 2 of natural log of sine. And just to make the result as obvious as possible, let me change the dummy variable of integration here, t. Let's go back to what we used in the beginning, x. So we get natural log of sine of x. All right, so let's notice what we have here. This integral was what we found after applying the peculiar property, or the king rule, in step 1, which is right here. And now we just need to work our way backwards from the result that we found. That integral equals the integral from 0 to pi over 2 of natural log of sine of x. So let's just go ahead and take our result from step 1. We are almost done. Integral from 0 to pi over 2 natural log of sine of x. And we found that this equals negative pi over 4 times natural log of 2. And now we're going to use the results of steps 2 and 3 here and replace this integral with this one, which is our original integral. Just be careful, we have that factor of 1/2 there. So we have plus 1/2. And the integral from 0 to pi over 2. And our function is natural log of sine of x. And after all this work, our original integral has come back. And this is setting up a simple algebraic equation that's going to allow us to solve algebraically for the integral. So here, all we need to do is just subtract this integral to the other side. And if you're just careful with the coefficients, look at this as having a coefficient of 1 in front of this integral. 1 minus 1/2 comes out to 1/2. So if I subtract this integral, we get 1/2 times the integral from 0 to pi over 2, natural log of sine of x, and that equals negative pi over 4 times natural log of 2. And our last step to solve for this beast of an integral, let's just go ahead and multiply this whole result by 2. And what we find is our integral from 0 to pi over 2 of natural log of sine of x, multiply this by 2 and reduce, you get negative pi over 2 times natural log of 2. And that is it. Now, again, all the work here was primarily applying a bunch of trig identities, but at no point did we ever find an antiderivative, which is kind of interesting. The key here was applying the peculiar property of definite integrals, or the king rule from the beginning, allowing us to rewrite this integral and set up this algebraic equation to solve for it. Hope you enjoyed this video and our ongoing series, The Art of Integration, where we're all about creative ways to solve integrals. If you're enjoying the content, you know what to do. Like and subscribe.